All right, let's talk about the concept of floating. I think the concept of whether a body floats or not is pretty straightforward. So a body floats if it weighs more, or sorry, if it weighs less than the buoyant force. So if the buoyant force is big enough, if the total weight of the object is less than the buoyant force that's created, it will float up to the surface. I think the bigger question is how much does a body stick up above the fluid line? So at some point it will breach the surface, and eventually what happens is volume, portions of the object no longer displace any fluid. So you have portions that poke up through the fluid boundary, and that portion no longer contributes to the buoyant volume of the object, or the displaced volume of fluid. And so what happens is, as the object sort of protrudes through the surface, both the magnitude of the buoyant force will go down because you have less volume being displaced, but also the center of buoyancy will change because the shape of the displaced volume is changing as well. And so, basically the object will keep going up until it finally reaches an equilibrium where the weight, the total weight of the object, which is basically unchanged as it goes up, is equal to the buoyant force. The buoyant force basically reduces as the object protrudes upwards. All right, and if you look really carefully, there's something kind of subtle that I did in this image, or the sequence of images, that also happens that is a little bit harder to see. So let me get my laser pointer here. So if you'll notice, initially when I had this submerged object, not only were the magnitudes of the buoyant and weight vectors different, but actually the locations of their centroids, so let's say the center of buoyancy was not in the same location as the center of gravity of the object. Not only were they not in the same location, but actually you'll see that they're displaced in a way that creates a net torque, or a net moment. And so what happens is, if you look kind of carefully, I tried to show that this object will actually rearrange itself. It will rotate itself until the center of gravity and the center of buoyancy are co-aligned with one another. They don't have to be in the same location, but they have to be co-aligned so that they produce no net moment. And of course, because the center of buoyancy is continually changing as the object protrudes, the object may actually rotate as it, moves up and protrudes through the surface. So that whole idea of, like a net moment being created by an imbalance between where the center of gravity is and where the center of buoyancy is, leads to the idea of stability, which we'll talk about in detail next.